Okay, so we have here the evapotranspiration. So evapotranspiration is the sum of evaporation and transpiration. And evaporation is the process wherein the the water is lost from the adjacent soil or water surfaces or from leaf surfaces. And the transpiration on the other hand is the water lost or that is lost yan, from entering the plant roots, and these are used to build up plant tissues and then out to the atmosphere through the stomata or the stomates. So if we are going to add up this evaporation and transpiration, then we will have the evapotranspiration. So this is very important when it comes to considerations in how much or how much water will you apply to the plants that you are, to the crops that you are planting. Because evapotranspiration will tell the crop water use. All right. So next, we have here the soil moisture conditions. So these are some. First, we have the saturation. So when we say that the soil is saturated or at saturation, all of the soil pores or yung void spaces are filled with water. So if that is filled with water, then if you're going to recall the soil as a three-phase system, the composition of soil is 50% solid and 50% water. So there is no more space for air. So this is not good for most of the crops, so except for rice, because rice is a water-loving hydrophilic crop. So many crops cannot withstand this condition for about 2 to 5 days. So if maglast yung saturated condition for 2 to 5 days, then most crops are malalanta or mabubulok. So the water move downward through the larger pores as percolation or drainage. So in this case, mas nagmo-move downward yung water. And for the pores to be replaced by air, it takes about few hours na madrain yung water in sandy soils. So for the sandy soil or yung soil texture na sandy, it will take few hours na mag-drain yung water. Whereas sa fine textured soils or the clayey soils, it will take 2 to 3 days bago ma-replace yung water, bago ma-replace ng air yung water na nandoon sa mga pore spaces. Okay. So here, if balikan natin sa hydraulic conductivity, so mas mababa talaga yung hydraulic conductivity ni clay soils, which has higher porosity compared doon sa mga sandy soils, which has lower porosity. Right? For the field capacity, so after the drainage has stopped, the large soil pores are filled with both air and water already, while the smaller pores are still full of water. So this is now the field capacity. Kung natigil na yung pag-drain ng tubig, like for example, meron kang pot na merong soil. Yan. Tapos nilagyan mo siya ng water. You fill it with water and then nag-drain siya ng nag-drain. So, pag nag-drain siya ng nag-drain, so yun yung percolation. So, once nag-stop na siyang draining, then that particular soil moisture condition is the field capacity. Habang nagde-drain pa lang siya, then that condition is in saturation. So here in field capacity, the water and air contents of the soil are considered to be ideal for crop growth. Kasi meron siyang water na makukuha yung plant, meron din siyang air para doon sa aeration para sa kanyang root zone. So, next is the term permanent wilting point. So, for the permanent wilting point or the PWP, this is the soil. This is the condition of the soil wherein the soil water content of which the plant dies. So, the soil here contains some water but hindi na siya nakukuha ng root zone. So, hindi na siya nakukuha ng roots. Hindi na siya nasisipsip ng roots. The uptake of water here is not sufficient to meet the plant's needs. And the plant loses its freshness and wilts. So, that is why it's called the wilting point. So, if the leaves change color, the leaves also changes color from green to yellow and finally, the plant dies. So, hindi na siya makarecover. Yan, at wala kang dinagdag na tubig, there is no water input. Then that is called the permanent wilting point when the plant will eventually die. So, we can picture this out further if meron tayong sponge. Tapos yung sponge, lagyan mo siya ng water. Yan. Pag-absorbin mo siya ng water, yan. There will be time na yung sponge is, pag nag-absorb siya ng water, merong pang tutulo na water. So, in that case, siya yung saturation condition. Pag nag-stop na yung pagtulo ng water sa sponge, yun naman yung kanyang field capacity. Kapag ka-press mo yung sponge, pagka-press mo ng sponge, di ba? Merong water na lalabas. Pero, yung sponge mo ay basa pa din. Meron pa ding water. So, at that condition, yun yung permanent wilting point. In that case, hindi na din magagamit ng halaman yung water na available doon sa, or of water na present doon sa soil. So, we have here figure. So, yan yung saturated, wherein all the pore spaces are filled with water. And then this is the field capacity with portion of the pores na merong air and merong water. And then this is the typical condition. Right? So meron kang air, meron kang mineral particle, and also have the capillary water, which will be useful sa plants. And we have here the wilting point. So, meron pa ding water doon sa nakadikit sa soil particles but it cannot be absorbed by the roots or it cannot be sucked by the roots of the plant. So, ang tawag din dito sa water na to ay hydroscopic water. So, it's the absorbed water. Right. So, we have here the term available water content or AWC. This is the amount of water available to plants. Balikan natin yung sponge na prines natin. Nung tumigil yung pagtulo ng water sa sponge, that is the field capacity. Nung prines natin yung sponge, merong water na lumabas, merong water na nag-remain sa sponge. Yung water na lumabas from the field capacity up to the wilting point is yun yung available water content. And this is the amount of water stored in the soil at field capacity minus the water that will remain in the soil at permanent wilting point. So, in mathematical formula, we have the field capacity minus the permanent wilting point. We can get the available water content. On a picture, yan, ito yung water content at field capacity. Ito naman yung water content at permanent wilting point. So, may gripo siya at field capacity. So, kayang kuhanin ng halaman. Itong permanent wilting point, up to that level lang. So, meron pa ding tubig pero hindi na enough para mag-flow yung water dun sa gripo. So, wala na ding para sa halaman. And so, the available water content here is this. So, the field capacity minus this one, ito lang yung available water content. And ito yung nagagamit or ito yung makukuha lang ng halaman. Alright? So, most of the crops have 50% yung available moisture content na makukuha from the soil. So, the field capacity, the permanent wilting point, and the available water content are called the soil moisture characteristics. And these characteristics are constant for a given soil, but they vary widely from one type of soil to another. So, ibig sabihin, si field capacity, permanent wilting point, and available water content ng clay is different from the FCP, WP, and AWC of the sandy soil. So, if you have also different areas and different soil characteristics, ayan, or different yung kanyang texture, then most probably magkakaiba din yung mga soil moisture characteristics niya. Alright? So, we have here another figure. Ayan. So, si field capacity, ito si wilting point. Ito naman si available moisture. Alright? But we have the term readily available moisture. So, bakit meron yung readily available moisture? Pag ikaw you're talking about irrigation, irrigating the crops, paabutin mo ba na mag-wilting point bago ka magpatubig? Di ba hindi? Kasi hindi mo naman siya paabutin na maging tuyot bago mo siya patubigan. So, we have here a readily available moisture. So, meron niyang measure din. So, that's, ito na yung 50% of the available moisture or 30% or 70% of the available moisture. So, you will be discussing this more in your higher subjects in irrigation. So, when the water is beyond field capacity, ang tawag doon ay saturation point. Yan. And when the water is beyond the saturation point, yan, that is the gravitational water or the superfluous water. So, balikan natin ulit yung sponge or yung paso na nilagyan natin ng patubig. Nung na-saturate siya, merong tubig na lumabas, 'di ba? Nung saturate, punong-puno ng tubig, merong tubig na nag-flow palabas. Yung either sa paso or either yung sa sponge. So, yung tubig na lumabas or nag-flow at saturation point, ang tawag doon sa tubig na yun is ang gravitational water. Ayan. And the gravitational water and the yung water from gravitational water up to field capacity is ang tawag doon ay ang superfluous water. So, kasi bakit superflow? So, from the term itself, nagpo-flow lang yung tubig pababa. Alright? So, okay, so we have here examples, computation. So, the field capacity of a given soil sample is 80%. In the cornfield having the same soil characteristics, the plant dies at moisture content of 50%. What is the available water content of that soil? So, the field capacity is given 80%. the permanent wilting point wherein the plant dies at moisture content of 50% is 50%. Yan. How do we get the available water content? So we just simply deduct 80 minus 50, so we have 30 as the available water content. Second example, the available water content is 45% and PWP is 30%. What is now the moisture content in the clay soil 3 days after it was saturated? So, and we have discussed earlier, after 3 days of saturation, ang state ng soil or ang soil moisture characteristic nun is the field capacity. So, field capacity is the available water content is field capacity minus permanent wilting point. So if you're going to manipulate, field capacity is available water content plus permanent wilting point. So we have 45 plus 30 and we have the field capacity as 75%. Okay. So we have here a combination. Okay. So the available water content is 50%. Okay. So the available water content is 50% of FC and PWP is 40%. If the soil sample, that is, if the soil sample collected at field is collected at field capacity, yan. The soil sample daw na collect natin at a moisture condition of field capacity. What is the fresh weight? Fresh weight of the soil when its oven dry weight is 125 grams. So in every problem, ilist down natin yung mga given. And we are given an available water content which is 50% of FC. So that's 0.5 of FC. And PWP is 40%. And we have an oven dry weight of 125 grams. So we find now the fresh weight of the soil sample. How do we do it? So first, we get the field capacity, right? So say field capacity, so we get the moisture content at field capacity. So how do we get this? So field capacity is equal to AWC plus PWP, and that is 0.5 FC plus 40%. So manipulating this one, we have FC is equals to 40 divide 0.5, and so we have the field capacity as 80%. So this is now the moisture content of the soil at field capacity, and ito yung gagamitin natin dito sa moisture content. So manipulating our formula on moisture content, the formula is fresh weight minus oven dry weight, all over oven dry weight times 100. So manipulating that one, we will have fresh weight is equal to 80 over 100 multiplied by 125 grams oven dried weight plus 125 grams. And so the fresh weight here is 225 grams. So if we are going to check, you may check 225 minus 125. Okay. Okay, so if we are going to check that one, so we have 225 as our fresh weight. So getting the moisture content, MC, equal to 100 multiplied by fresh weight minus oven dry weight all over oven dry weight. So our MC is 100, 100 multiplied by 225 minus 125 over 125. We should get an 80% here. So is that 80%? We have 225 minus 125 divided by 125. And so that is 80%. So our solution is correct. Okay. So we have here, that's for the soil moisture. So next is we have the water balance. So for the water balance, so this is just equal to the amount of water being input is the amount of water output. Now water in is equals to water out. So here, the amount of stored water, S is equal to the precipitation plus irrigation minus the runoff, the evaporation and transpiration, and the percolation. Right. So this is the stored water. So nagkakaroon lang ng storage or nagkakaroon lang ng water na nai-store sa soil if precipitation plus irrigation is greater than the runoff plus evaporation and transpiration plus the percolation. Okay? So this is an introductory to your irrigation or higher subject. And that's the end of the slideshow, but we